The next function we'll have to implement in exercise A01 will be the int array underscore clone function. This is meant to do a replica of an existing array, which the array and the size are passed here as parameter, to make a replica of this array, allocate it in memory, and then copy all the elements of the data array in the new replica, and then return its address, of course. As you can see, if we have problem allocating, then we are going to return null. So obviously, we are going to rely on our intarray allocate function, which returns null if something went wrong. So let's go to all.h, and I'm going to cut and paste here this signature. I'm going to add it to this file. Okay. And while I'm at it, I'm going to go ahead and cut and paste the gather and extract once as well. So there we go for the next function we'll have to write. So we can then just work on our function without having to worry about filling in the blank in the all.h file. Okay, so I'm going to do what I did with the previous function. I'm going to cut and paste one block, those guys here. And I'm going to make sure my file is saved, and I'm going to go back to all.c, where I'm going to paste those function signature. Okay, there we go. No, almost. There we go. Okay, I'm going to give them an empty body for now. And start just inserting return statement to make sure that they compile. So this one is supposed to return an int star. I'm going to make it return null by default. This one is supposed to return also an int star, a newly allocated dynamical array. I'm going to make it return null. And once again, I realize that I switch in between styles with a curly brace placement. So I'm going to rectify this on the fly. And this one is also supposed to return a newly allocated array. I'm going to make it return null by default. So this is what I have so far. And we are going to start by working on the intarray clone function. So we know that this array data here is of size. So the first thing we need to do is to allocate a new dynamical array, which is going to be large enough to accommodate all the elements inside of data. So we can use int array allocate to this one. And int array allocate just asks us to specify a size. So we have the parameter size here that is going to do just fine. Now, depending on whether the allocation was successful or not, the pointer p here will be equal to null or not. So I can check that really easily. Okay, if p equal null, which I can write if not p. If not p, return null. Return p would be just as good. So I got rid of the problems here. If I cannot do my allocation, then I return null immediately. Then what I need to do is I need to be able to actually go through the array data, and I need to copy element by element inside of my new replica. So this is a counter-controlled typical loop. Okay, so I'm going to use int I as an index variable, I equals 0, I lesser strict than size, I plus plus. It should be like a pattern, automatic pattern almost by now. And I'm going to use array notation, p index I is equal to data index I. What else should I verify here? Well, if I really want to make my library robust, I should make sure here that data and size are actually valid element. If size equals 0, when I try to allocate, this is going to return null. If size is lesser than 0, same thing. So once I am past the allocate step, I know that size was correct. Now what about data? Data is going to be the address of an array. Maybe data is going to be null. If data is null, there's nothing really I can do. So I could test that here after I already allocated size. But if I am past a data pointer which for some reason is null and a size that is appropriate, like 3 for example, I'm going to allocate something, and then I will have to deallocate it if I realize that I cannot make the copy. So I'm going to test if data equal null. First thing, if data equal null, then I return null. I cannot do a copy of a null array. Then I test if the allocation went wrong, I return null. Then if I'm here, that means the data is not null, and the allocation went okay, so I can do my copy. There are a couple more things that could go wrong, but right now we're going to assume that here, at this point, everything is fine. And once I'm done, I'm going to return p, which contains the address of our newly allocated array. Let me save this. And now I can go to, well, first I can make sure that I didn't introduce a volley of syntactical error. Well, actually, talking of which, okay, line 8, syntax error before the colon token. So I'm going to go to hal.c, line 8, and I put here a colon instead of a semicolon. That might take care of a couple of the following syntactical errors, so I'm going to recompile. Syntax error now, line 11, apparently I did the same thing. Hal.c, line 11, yeah. Okay, let me double check if I didn't play with that, the rest of the function, no. So I'm going back to Conqueror, compiling again. That was it. So I could run it right now, but this is not going to do me, how to say, any good at all, because I didn't call this new function. So I'm going back here to hal.c. I have my intarray clone function, and now I'm going to move to test.c, where I'm going to test the clone function. So test intarray clone, and I'm going to cut and paste this call to put it here as a signature, and cut and paste the signature of this new test function so that I can start defining it. There we go. So what do I need to do to test my intarray clone function? Well, first I need an array. Does it need to be a dynamical array? No. So I'm going to declare an array, call it my array, why not? This is going to be an array of 3 integers, initialized to 1, 2, 3. Then once I'm done with that, I'm going to try to make a clone of this array. So I need a pointer, and I'm going to assign to this pointer the result of calling int array underscore clone, and I'm going to pass to this function my data, which is the array I want to clone, and its size, which is 3. What I'm expecting out of intarray clone is actually a copy of the array by array, of same size, etc. So, first thing I'm going to check, if p equal null, I couldn't allocate for some reason, or something went wrong. Well then, printf error int array clone of my array 3 didn't work. And at this point, if it didn't work, I cannot really check anything anymore on p. Okay, p is null, so there is really not much I can assess further on p. What else could go wrong? Well, what else could go wrong? I could have a copy made, but it could contain different data than the original data. Okay, I don't have a very easy way here to check the size of the copy that was returned to me, so I'm going to have to leave this out, but I can check the content. So if p equal null, I'm going to display this error message, and I'm going to exit my program. Okay, something was wrong. I cannot test any further with p, so I'm just getting out. Now, if I didn't get out of my program, I can now test the content itself. What can I use to test the content? Well, let's go to hal.h. We have a lot of code written already for those functions, so we might be able to find something. Intarray compare by position. Give the 2 arrays, give their size. That looks good. So I'm going to be lazy, and I'm going to cut and paste here this. So I can use it to type my call to that function. So I'm back inside of test.c. And I'm going to now compare. Compare what? I'm going to compare my original data, my array, with a dynamical array pointed to by p, and I'm going to pass size 3. When I call this, let's go back to hol.h, I expect an integer in return. So hol.c, let's have a look at this function to remind ourselves of what are the return value. Compare by position is here. Return 1 if they are equal, return 0 if they are different, true or false. So I can go back to test.c, and I can store in a variable, let's call it result, the return value of calling this function. And what I'm expecting here is that result should be true. So if result equal false, the function tells me those two things are different, I have a problem. So result equal false can be returned if not result. And if not result, printf error int array clone produced erroneous content. It's relatively general, but that will help me pinpoint exactly which test failed in this file. So I have here the call to compare by position. What else can go wrong? Well, let me see. The allocation didn't work, so I got a null. The size was not correct. I got a null. So that means that if I keep trying here, calling my intarray clone function with a null pointer or a size of 0 or negative, I should still keep getting nulls. So I'm going to do that. I'm not going to deallocate my p here because my point here is just to test, okay, the functions, and I want to just focus on intarray clone. So I'm going to let it dangling for now, but I'm going to use another pointer p2, and I'm going to use p2 actually to try to allocate, not allocate, but try to clone my array when I specify a size of 0, and at this I expect will return null. So if p2 different than null, then I have a problem. Printf error int array clone of my array 0 is where my problem is. And then I'm going to test similarly p2 equal int array clone of my array -3. So that's going to allow me to test that this function detects actually when a parameter, the size parameter, is actually negative. So printf error int array clone of my array -3 is where my problem is located. Last thing I mentioned, what if I try to do p2 equal int array clone of null? And I'm pretending this is an array of size 3. Well, same thing, I'm expecting int array clone to detect this. So p2 different than null mean I didn't do my job. Printf error int array clone null 3 is my problem. There we go. So we have a mini battery of tests here that should be like sufficient for a start. I'm going to save this file and let's weed out syntactical errors by trying to compile it. No syntactical error. Let's give it a first run. No errors were detected, which means that every single case that we processed in the test function was successfully handled by our, and let me scroll up here to put back the code on the screen, our intarray clone function.